All right, 5.7, example 12 is talking about multiple angles. And remember, multiple angles give us multiple answers. This is the one where we made the charts before. All right, so tangent of 2x is equal to the square root of 3, and we want to look between 0 and 360 degrees. Notice this one's a little different because we haven't done it where they're in degrees before. So, but it is possible if they tell us that our interval is in degrees, which this one has. All right, so the only thing that's different, instead of writing x equals like we normally would when we go to solve this, we're going to write 2x equals. Now, what quadrant are we in? Where is tangent positive? Well, tangent is positive in quadrant 1 and in quadrant 3. Now, remember, for this to be tangent, tangent is y over x, which means my y is going to have a square root of 3 and my x is going to have a 1. So when we look at this as an ordered pair, the only thing we have similar to this is if they both had a 2, and because this is a fraction, y over x, our 2's would cancel. So we know it's going to be 1/2 and the square root of 3 over 2, or they're both going to be negative. Alright, so look in quadrant 1. Which one has an ordered pair of 1/2 and the square root of 3 over 2? And hopefully you're saying, now remember we're going to be in degrees this time, hopefully you're saying 30 degrees. No, I'm sorry, 60 degrees. And then in quadrant 3, the only difference in quadrant 3 is we know x and y are both going to be negative. So I want the negative 1/2 and a negative square root of 3 over 2. And that's going to be at 240 degrees. Alright, and so what we did before with the multiple angles is we added plus 2 pi n. But remember, this isn't 2 pi now, this is 360 n. So we're going to put plus 360 n. And then we need to solve for x, so we're going to divide everything here by 2. And so we get x equals 30 plus 180 n. And same thing here. Sorry, it's a little crowded. We're going to divide by that 2. And so we get x equals 120 plus 180 n. And this is where we made our table. We picked some n values. Remember, we started at -1. My first one is 30 degrees plus 180 n. And my second one was 120 degrees plus 180 n. And then what we did is we went in and we plugged in the n values. So for this first one, we got 30 plus 180 times -1, which is 30 minus 180, which is a -150, which is not between the 0 and 360. So this one's out. We did the same thing with the 120 plus 180 times -1. So it's 120 minus 180, which is -60, which is not between 0 and 360, so it was out. That's what we want, though. We want it to be too small at first, and then we're going to just increase our n size by 1 until we find where it's too big. So when we plug in 0, we get 30 plus 0, which is 30 degrees. This is a solution. It's between 0 and 360. Plug in 0 to the other side. We get 120 plus 0, which is 120 degrees, which is between 0 and 360. Then try 1. So 30 plus 180 times 1, which means 30 plus 180, which is 210 degrees, which is between 0 and 360, so it's an answer. Plug in 1 over here, so 120 plus 180 times 1. That's 120 plus 180, which is 300, which is between 0 and 360, so it is an answer. And we're going to keep plugging in n values until we get numbers that are too big. So I'm going to plug in now n is 2. And so I get 30 plus 360, which is 390, which is not between 0 and 360, so it's too big. So I know in that column that 30 and 210 degrees are my only two solutions from that column. Now, in the other column, we're going to continue. So I got 120 plus 180 times 2. So 120 plus 360, and that's what, 480? Which is not between 0 and 360, so it's out. So there's our 4 answers. We have 30 degrees, 120 degrees, 210 degrees, and 300 degrees. And you can rewrite them, or you can just leave them boxed inside the table there. I can see them. So there's our solutions.